Hello everyone and welcome to week 6 of CCCS121 Programming 2 at University of Jeddah. Um, Today, this week, we're going to start getting a little deeper into object-oriented design. Um, so Today we're just going to do um, a few minor topics, some easy stuff to start us off. So the first concept I'm going to talk about is immutable objects and classes. So the thing that you need to know is immutable. This is the Arabic translation I found for it. Um, Immutable is the opposite of mutable, um, which comes from the word mutate, so change. Mutable means being possible of change. Immutable is being unable or not having the ability to change. So immutable objects and classes are ones in which um, member variables um, take on certain values at the time the object is created, and those values cannot be changed for the remainder of the existence of those objects. So, like so often, I'm going to do an example of that. So I'll open up this project week 6.1, and let me begin. Let me add a class. Let's call this one customer. And let's say this customer class has a couple of data members. So I'm private. So of course, all uh, in order for the data not to change afterwards, all those data members have to be private, of course. Um, so let's say we have a customer ID. We have a string that contains first name. We have another string that contains the last name. We have um, another one that contains, let's say, the Ikama number, and because I'm trying to demonstrate an application of an immutable class, I'm not going to add any other fields. I'm going to keep the data members restricted to data members which you would ordinarily not expect to change for a customer. So a customer ID, first name, last name, and let's say the Ikama number also doesn't change. Okay. Um, so I'm going to use this class actually to demonstrate a couple of concepts. So first off, let's make a constructor, one that takes an ID, a first name. Actually, we can use different name fn, another string which is the last name, and another long which is the Ikama number. And in the constructor, I assign these values to the member variables of the class. There you go. And we have a useful constructor that we can use to initialize uh, an object of type customer. Um, and because it's good practice, I'm also going to make a no-arg constructor to control how Uh, these values will be initialized when none are provided. Do some copying and pasting. There you go. Okay, so we have two constructors, and so in order for these, so if this class is to be an immutable class, that means that I cannot have any set methods for this class, which means uh, the remaining methods that I'll have, the remaining accessor methods that I'll have, public, um, so get ID, which will return the customer ID. I'll have another one that returns the first name, return first name, another one returns the last name, and last one which returns the gamma number. Oh, there you go. Okay, and that's it. That's our class. As you can see, this class, 4 data members, all private. I can set these values in the constructor. If I don't provide any arguments, they'll be set to some default values. And since this method has only get methods, no set methods, this means that once the object is created, I have no way of changing these these data members of the customer class. This makes the customer class that I made here an immutable class. That's it. That's basically it. That's all about. It's pretty much almost all about immutable classes. There is, however, an interesting example in the slides. This one. I want you to take a look at this and see how. In this example, we have a class student. It has it has two private data members, an ID and a birth date. And on top of that, we don't have any set accessor methods. We have a get ID, we have a get birth date method. Um, birth date itself is an object of the class birth date over here. So with only these two methods, nevertheless, it is still possible to make changes to these, to the birth date, even though there's no set method. Please go through this example and try to figure out why that is. It's actually quite straightforward. And it relates to something that we have already studied earlier. But generally, um, an immutable class is made by keeping all data members private, providing no mutator method, no set variable methods, no set methods, only get methods. But the get methods have to be ones that do not return objects. Okay, I'm already giving you a hint for what's going on there. Okay, so let me go back to the example and show you something else. Okay, so a few of you guys in class have been using the this keyword. This has a special meaning in Java. This is basically a reference to the object in which you're using the this keyword. It's a reference to the object itself. Okay. Now, why would we ever need that? I mean, we didn't need it up to this point, so why have it at all? Um, so let me show. So let me show you a possible use. So over here, remember our customer class had two constructors. This one, which takes values for the data members in the argument and assigns them to those data members um, at the time the object is created. Over here, I'm assigning four values, 0, unassigned, unassigned, and 0, to these four data members. Kind of the same thing that this customer constructor method is doing. Now, since I already have this method, which is assigning four given values to the data members, I can actually reuse this method in here. I can actually call one constructor of a class inside another. Let me show you how that goes. And in the process, I can actually cut down on these 4 lines of code, and I can replace them by a single call or one line of code like so. Oh, sorry. There you go. Actually, to let me just comment these out and put in a comment. Does the same thing as dot dot dot. Now this, the keyword, as you can see, is highlighted in blue. This is basically a stand-in for the word customer. Okay, so this will call the customer constructor method and pass it 0, unassigned, unassigned, and 0 in here, which will basically do the same job as these 4 lines did earlier. So this is one use of this keyword. As another one, let's take a look over here. The names of these variables in the argument of the customer constructor method have to be different from the names of those same quantities uh, given here in here for data members. It would be much more. So basically, we have to deal with. We have to when you read this code, you have to remember that I contains a customer ID, and ID also contains a customer ID, which is uh, uh, well, you have to keep track of even more variables for the same quantity. It would be much more convenient if we could give these arguments the same name as the member variables. Problem with that, though, is that when you do that, I'd have to modify the code like this. You can see that these 4 lines I'm already getting trouble over here. I'm already getting warnings. I'm assigning a variable to itself. That's what it's telling me. Which of these ID over here, variables over here is which? How do you expect the compiler to know that ID on the left is this ID, and ID on the right is this ID that you're passing as an argument to the constructor? So one way to distinguish between these is you can use this keyword to say that, hey, this last name is the last name that belongs to this object I'm currently in. So when I say this.id, this clearly identifies the ID variable as the ID member variable. And the other one, left as it is the ID that is being passed to this method as an argument. So as you can see, this makes the whole code a lot more readable, and as someone who has to review or who's reading this code, um, you have to keep track of fewer variable names. So this is another use case uh, for the this keyword. So just to come full circle, let me make let me make a customer object. Let's call this one C1. Okay, and let me pass some values here. So the first one is a customer ID. Let's make this the first customer, customer one. Um, Name is, let's pick someone. First name Ali, second name, last name Hussein, and Ikama number. Let me make something up. Oops. Don't even know if it's the right number of digits, but that's okay. Okay, so this will make, oops, oh, this is not a string. Sorry about that. Okay. Okay. All right. And the error we're getting is integer number too large. So apparently this number is too big. Reduce that. There you go. Okay. All right. So we have customer over here. I guess it would be better to make this a string. User. Okay. And C1 dot get ID. Let's print that out. And do that. Sorry. There you go. And just like that, we can do that with all the other fields. So we have ID, first name, last name, comma, and print those out. There you go. Customer 1, Ali Hussein, and has the comma number. And just if you want to see if this also works, if the other constructor also works, let me make one C0, another customer. Let me not give anything for our argument, and let me print out all those values. Let's take a look. So let's put a blank line between the two. So you can see first customer was created as intended. For the second one, we used the no-arg constructor, and that was for the second object C0. All data members were initialized as 0, unassigned, unassigned, and 0, uh, just like we wanted to, just like we specified over here in the no-arg constructor, and that no-arg constructor is in turn calling the before argument the other constructor that we have. Okay. So this small demonstration shows you what an immutable class is and how you can make use of this keyword that references an object itself. So I'll see you all in class on Sunday. Have a good rest of the weekend.